Please see the descriptions for timestamps so you can go to the axis symmetry that you're looking for. We're going to look at a horizontal axis symmetry, vertical axis symmetry, and also diagonal axes of symmetry. So let's start with horizontal axis of symmetry. When you're reflecting over a horizontal or a vertical line, it is pretty much as easy as just counting the spaces. So over here with S, we're reflecting over this line right here, y equals 3. So we're just going to count 1, 2, and then go 2 more units in the other direction. So that way we're doing 2 units away from the axis of symmetry. So up 2. So S prime is located at -3, 5. And again, we know that the axis of symmetry is a perpendicular bisector of the line segment joining the pre-image to the image point. And so that means it's cutting this segment in half at a 90-degree angle. And we know the axis of symmetry is horizontal, and so that line segment joining pre-image and image points is vertical, and horizontal and vertical lines are always perpendicular. So we know we got that part taken care of. So now we just gotta make sure that segment was bisected, and it is because we made sure to go up 2 units from the pre-image to the axis of symmetry, and then 2 more units away from the axis of symmetry. So that means that it was a segment that has a length of 4 units, and we split it into 2 congruent segments that have a length of 2 units. And that's pretty much all there is. Anytime you're reflecting over a horizontal line, it's as easy as just counting that distance. All right, let's look at a vertical axis of symmetry. So over here we have the vertical line x equals -1, and we're reflecting h over that. And so we can just count that distance from h to the axis of symmetry. So we have 1, 2, 3, 4 units. So we're going to go 4 more units. 1, 2, 3, 4. So h prime is going to be at 3, 3. So when you're reflecting over a vertical line or a horizontal line, it really is as easy as just counting that distance. And the reason why that works is because the axis of symmetry is the perpendicular bisector of the line segment joining pre-image to the image. So perpendicular lines have opposite reciprocal slopes. They intersect at 90 degrees. And anytime you have a vertical and horizontal line, they're going to cross at 90 degrees. So we got that part taken care of. Now we just have to make sure. So yeah, we've made sure to have that perpendicular part. We have to make sure the axis of symmetry also bisects this line segment, which is why the counting method works for horizontal and vertical axes of symmetry. So we know this line segment has a length of 8 units, and so half of that is 4, which is why we're doing that 1, 2, 3, 4, 1, 2, 3, 4. So now let's look at the method for reflecting over a diagonal line. So we're going to reflect over this diagonal line, and as you can see, it's not as easy as just counting the distance because we can kind of eyeball that A prime should be maybe somewhere over here in the first or fourth quadrant, but it's not quite clear. So we have to do a little bit more work. And so what we need to make sure is that we're using that idea of the line segment connecting pre-image and image points being split in half at a 90-degree angle by the axis of symmetry. That's the goal. So we need to make sure we get that 90-degree angle, which is going to happen from making sure the axis of symmetry and that line segment are perpendicular to each other. So the first step is just to find the slope of the axis of symmetry. So we can see that we're going up to 3 over 1. So the slope is 3 over 1. Now to make sure that we have 2 perpendicular lines, we got to have the opposite reciprocal of 3 over 1, and that's going to be -1/3. So what we need to do is to start at our pre-image and use the slope of -1/3 to make that line segment started that we want from the pre-image to the image. So we go down 1 over 2, 3, down 1 over 2, 3, so on and so forth. So now we know that the line we drew in red and the axis of symmetry are perpendicular. So the next step is to make sure that axis of symmetry bisects that line segment from your pre-image point to your image point. And so if you notice, you can go right here, you've got a point of intersection at 0, 2 from the line we drew and the axis of symmetry. And so we can find the distance from A to that line of symmetry using the distance formula. Or in this case, we can just kind of see that we went down 1 over 3. So in order to make sure that line segment was bisected, we can go down 1 over 2, 3. So A prime should wind up here at 3, 1. And perhaps you can see a little more clearly here that we have the axis symmetry, that is bisecting this segment joining A to A prime at a 90-degree angle. So this distance is split in half. Okay, our last example is just looking at reflecting a shape. It's the same process. We're just going to do it 3 times in this case because we have 3 anchor points. Notice that we have a diagonal line that has a positive slope, and we did in that last example too, but the process works the same for a negative sloped axis of symmetry. So the axis of symmetry has a slope of 1/1, so the slope of the line perpendicular to that has to be -1. And so what we're going to do is pick a point to start with and draw a line through it that has a slope of -1. Let's start with just x. At this point, you have 2 options. You can continue on and do a line with a slope of -1 through y and through z, or you can go ahead and figure out where x prime should be. Let's go ahead and figure out where x prime should wind up. So right now we know that there's a point of intersection from that red line and the axis of symmetry at -3.5, 1.5. So we want to make sure that the axis of symmetry also bisects the line segment joining the pre-image and image points. So we just got to find the distance. It looks like we went down 1.5 over 1.5. So we want to do the same thing, down 1.5 over 1.5. And so x prime is going to be located at -2, 0. So let's repeat the same process for y and z. So we can see there's a point of intersection at -1.5, 3.5. So we want to find that distance. We go down 1, 2.5 over 1, 2.5. So now we want to go down 1, 2.5 over 2, or 1, 2.5. So y prime is going to be at 1, 1. Now we're going to draw that line segment that's going to be perpendicular to the axis of symmetry through z. And we're doing this so that we can find those points of intersection of the line we're drawing and the axis of symmetry. Okay, and that looks like it's probably going to be good enough. So now we just got to find the distance after we find that point of intersection, which is going to be right here at -2, 3. And if we find that distance, we're going to go down and over and do that same distance. So we're going to go down 2, 3, 4 over 2, 3, 4, and we're going to be at 2, -1. And then we just have to connect our vertices, and that's going to be our final image. Let's go ahead and clean this up a little bit so that we can see more clearly the reflection. So as you can see, we reflected over this line, and we can tell we reflected because the orientation of the pre-image changed. So if you look at the pre-image, we went from x to y to z in this motion, which is counterclockwise. But over here in the image, that same motion is now clockwise, and that's important. That's how you know you reflected correctly. And then also if you're connecting x to x prime, we can see that that line segment is perpendicular to the AOS, and it was also cut in half by the AOS. Same thing for y to y prime and z to z prime. All the other points obviously had the same thing happen, but it's easiest just to focus on the anchor points of your shapes and then just connect your line segments. And that's how you do a reflection.